Welcome back to Edutainment. In this lecture, we will be studying about the gaze system. In our previous lecture, we studied about positioning of our furniture or the models from the asset store. So let's quickly move to the Unity. So in our previous lecture, as I told you, we just created or we just imported some of the models from Unity asset store like the bar chair, the table and the chair and the lamp too. So, in this lecture, I will be showing you how you will be implementing or how we will be creating a gaze system. So, in our previous lecture, I told you like what is a gaze system. Gaze system is the view or we can say the rays that are coming from your eyesight. Okay. So, first of all, creating for those kind of a gaze system, we will be creating a game object that is a 3D object. We will be creating a sphere. Okay. So, this is a sphere. First of all, I will be decreasing the size of the sphere and I will be positioning it in front of the camera. So I will be from the transform, I will be putting the values of 0, 0, 0. Okay, so this is the value of 0, 0, 0. Now this is the camera that we are having, or we can say the player class. So I will be shifting this sphere into camera over here. Then I will be placing this sphere in front of the camera. As you can see in the game view, the sphere is in front of the camera right now, but this is a very quite or we can say a huge sphere. So I will be again decreasing the size of this sphere so that it will be looking like just a point or we can say a reticle. Okay, so now you can see this is a small reticle over here. Why did we added this sphere in the camera? We added the sphere into the camera or in the player class because when you will be running the because when you will be running the Unity software or when you will be playing this, your sphere will be moving along with the camera or we can say with the player. So it will be acting like a gaze system. So let me show you an example right now. I will be playing this thing. So you can see this is a sphere. I will be moving the sphere. So you can see in my scene that there is the sphere is moving along the axis of the camera. You can see. So I will be moving up and down. You can see that the camera is moving along and the sphere is moving along with the camera. But there is one problem. You can see in the game view, I will be showing you in the game view, the sphere over here is not trending through the walls. It's just clipping throughout the walls. So first of all, we have to make this change also. We will be rendering the reticle over here. So I will be stopping this thing. For that, you will be creating a material. So you will be going over here, you will be creating a material, name it as reticle. Okay. In this, you will be selecting the shader as Google VR shader and you will be clicking on reticle. When you're done with this, you will be just dragging it towards the sphere. So you can see that there is a white reticle on the sphere. So while you will be clicking on the sphere, you can see there is a component added named as Google VR reticle. So now I will be again playing it and you can see it is not clipping throughout the wall. Now it's getting rendered and you can see, okay, so it's not passing throughout the walls. It's just moving around the walls. You can see right now as I'm moving the camera, the reticle is moving along its axis. Okay, now we will be making some kind of an update because we need to create a raycast. Raycast is an infinite line that will be passing throughout the objects and allowing you to teleport the objects from one place to another. Or you will be selecting some of the objects too. So for that we will be creating a raycast. Okay. So for creating a raycast, we will be creating a new C# string. Okay. You will be naming it as reticle. Over here you can name it as reticle script, and you will be opening the script. I usually prefer Notepad++, but most of them prefer Visual Studio. So it depends upon your preferences that you can go with the Notepad++ or with the Visual Studio. So first of all, like we will be starting, we have a named class reticle that is having a mono behavior. So the void start, we have two functions over here, the void start and the void update. The void start, it always starts before, means it only runs once, and where the update always runs every frame per second. Okay, so you can see over here the start is called before the first frame update, and afterwards the update function is called per frame. Okay, so now we will be creating a function that will be helping us allow to know what should be passed through the object, or we will be creating array cast. Okay, so first of all we will be creating a function that is public void process case. Okay, this is a function that I have created. In this I will be writing about, there is a function that is predefined by the Unity that is for creating a raycast. So that is raycast ray, that is equal to new ray transform dot position. This is the position of the camera that it will be getting towards over here, and then transform dot forward. So the raycast will be passing throughout the camera in a forward direction. That is the direction that we are giving over here. Okay. Now we need that if the raycast hits some object or a model, so it must send some value. So we have to store that value. We'll be writing raycast hit. That will be storing the information hit info. Okay. Now I will be putting some condition over here that if physics, this is also a predefined functions from Unity. So raycast, in which I will be writing raycast ray out hit info. Okay. If there is an object and we are getting some information stored in hit information, and if this condition is true, we can perform some action over here. Okay. Now, for developers, we can use a debug that will be helping us to know, it will be drawing a line throughout the camera so that we will know that the raycast where it is throwing its ray on the specific object. So we'll be writing debug draw ray raycast ray dot origin, that is from the origin, that is from the camera point, to the raycast ray dot direction. We will be multiplying that thing into 100, we can say, so that we get a complete. Okay, it will be multiplying the direction into 100 so that there will be an infinite line for the ray. Okay, so now we will be updating over here. We will be calling the function that we have created, that is process case that we call. So we will be calling the function over here. Just save this application with the, just save this notepad, and now take this script and put it on the reticle because we need the reticle. Now playing. So we have some kind of errors over here. So this error is that on 29.2. So we will be going on 29.2. So there is a bracket that we are missing over here. So we will be putting the bracket. Then we will be saving this function file again, and then we will be going back and again playing. So these are some of the warnings. So over here you can see when I'm playing over here, there is no kind of a difference. But when you are seeing in the scene view, you can observe that there is a long infinite ray that is passing throughout the reticle. Okay, so this is the debug ray card that we have created. So it is passing through the center of the reticle, and when we are moving this thing, it moves along with the reticle. You can observe that thing that it's moving. Like if I'm passing this object throughout, when I'm passing this string, when I'm looking at the table. So this reticle has a ray card that is penetrating through the table, and we will be along this we will be able to select that object and transform this object from one place to another. So we have created, or we can say this is the first step of creating a gauge system. In our next lecture we will be talking about implementing more future, we can say a more complex structure regarding this thing. Thank you.